Hey everyone, we're going to be going through some problems where we're involving area of a sector of a circle and arc length and mixing the two formulas together. Let's show you how it's done. Just as a reminder, let's review the couple formulas we're dealing with area of a sector and arc length of a circle. Say you have some circle with a radius that you know and some sort of central angle, then you can find that area of the sector that the central angle's in. And a sector is just like a slice of pizza or a slice of pie. You have to be able to have the angle inside of there. And we usually call that angle theta. And since a circle is 360 degrees, we just divide that by 360. And then we multiply it by the area formula of a circle, which is pi r squared. So that's the general formula for area of a sector. Now, if you're more interested in knowing what the length of the arc is the part of the circle that's kind of snipped off. That length is a portion of the circumference. So we'll still use the same degree. You take that degree, you divide it by 360, but instead of multiply it by pi r squared, we multiply it by 2 pi r, since the circumference formula is 2 pi r. So that will get you the length of that portion of the circle, which I usually call L. There's another formula that you'll see that length called S, but it still means length. So A for the area of a sector, L for the arc length. So let's get into example 7. A circle has a radius of 8 feet. Find the area of a sector that has an arc length of 12 feet. So let's just look at the question first. It says find the area of a sector that has an arc length of 12 feet. The question wants to know the area, and they're giving you the length. And I'm going to leave off the units for now. It does give you the radius. So since the radius is 8 feet, we're going to be able to use that in both formulas. Let's pause for a minute and look at the two formulas. Now, since we want area, we would need to be able to have the degree measure, which is that theta symbol, and the radius. Now, the only thing we have is the radius. We know that the radius is 8, but we don't have the angle, and we can't find that until we know what the angle is. So what we'll have to do is we'll have to use the length formula. Since we're given the length, that length is going to be 12, and that radius is going to be 8. We can plug those in, and we can figure out what the angle is by working backwards. So let's rewrite first the length formula and plug in the numbers that we have. We're going to say 12 equals theta over 360. If you don't like that symbol theta, you can use x if you want. You just got to remember that it stands for the degree. So we know that the radius is 8, so we'll say 2 pi times 8. Now what we'll have to do is we'll have to work backwards to solve for theta. So to help, I cleared all the rest of the stuff out so we can just focus on this equation right here. So since we're trying to solve for theta, we'll have to get rid of this 360 and the 2 pi 8. We can actually multiply both sides by 360. So if we do that, that's going to give you times 360 by the 12. And if I multiply by 360 on the other side of the equation, I'm going to get rid of that 360 on the fraction. So let's do that on your calculator. And that's going to give us 4320. So we'll rewrite the equation. 4320 equals theta times 2 pi 8. There's no more fractions, so I'm just going to write times 2 pi 8. And if you want to combine the 2 and the 8, you can say 16 pi. But we have to get rid of that 2 pi and 8, and they're all being multiplied. So the best way to do it is just divide by everything there. So I'm going to put everything over 2 pi 8. Now you got to be careful when you're calculating these. You can divide them separately or use parentheses when you're dividing by the whole thing. So I'm going to choose to divide it all at once, but I will use parentheses around the 2 pi times 8 to basically cancel everything out at once and have to not deal with a whole bunch of calculations. So on this calculator, now be careful with each calculator. Everyone's a little bit different, but 4320 divided by, what I'll do is after the division, I'll hit parentheses. I'll do 2 pi 8. You can type the 8 right after the pi if you want. If that worries you, just put up 8 in parentheses if it makes you feel a little bit better about dividing. Make sure you have the right number of parentheses, and that'll give you a degree measure. And that's going to solve for the degree. I'm going to round that to 85.9. On paper, I can write 85.9, but when you're using your calculator, you can use your previous answer and utilize all the decimal places. So now that we have that degree and we know what the radius is, we can go back into the area formula and we can figure out what that area equals. So since our area is the degree over 360 times pi r squared, I'm ready to plug everything I have in. So take a moment, you can pause the video and plug them in yourself, and then you can unpause it and see what I get. So I'm going to do 85.9 on paper, but I'm going to use all my decimals on my calculator to get a more precise answer. So divided by 360 times pi, and the radius is 8 squared. So let's key all that in. What I'll do here is I'll use my previous answer, and I'm just going to hit divide by 360, and then I'm going to hit times. We'll do pi, so second exponent. The radius is 8. I usually plug that in parentheses and hit the square button. That's going to be the exact answer. Now, if you used 85.9, you might have a decimal, but it should be right around 48. And the unit here is feet, so since it's area, it's going to be about 48. Well, it's actually exactly 48 square feet. So I'm going to write 48 feet squared. All right, make sure you write that down. We're going to move on to the next question. Let's look at example 8. A circle has a diameter of 16 centimeters. We want to find the arc length of a sector with an area of 14 square centimeters. This time we're given the area and we're trying to find the arc length. So we don't know the arc length. We'll put a little L equals question mark. We know the area is 14 square centimeters. I'll leave off the units for now. Since the diameter is 16, we always really work with the radius on these problems. So I'm going to write the radius is 8. Remember, the radius is the diameter divided by 2. So what I'm going to first do is I'm going to write the area formula. Because since I have the radius, then I can find the degree measure and I can plug that into the length. So the area is the degree measure, theta, over 360, multiplied by pi r squared. I'm going to plug in 14 for A, and I'm going to plug in 8 for R. So 14 is going to go here, and 8 is going to go right there. And once again, we're going to find that degree. So let's rewrite this as 14 equals theta over 360 multiplied by pi times 8 squared. Now I'm going to do this very similarly to how I did in the previous problem. I'm going to want to multiply both sides by 360 to cancel out that 360 here. And that's going to give you a larger number, but remember we're dividing a whole bunch of stuff out. So go ahead and figure that out, and let's rewrite this. So 360 times 14 is going to be 5040. We'll rewrite that as 5040 equals pi times 8 squared, which is also 64 pi if you want to just leave it, without the square there. What we want to do next is divide all that stuff out. Oops, I forgot the theta. So let me squeeze that in there. Divide that pi times 8 squared out so we can solve for theta. And make sure you're using parentheses if you're using this calculator. If you're on Desmos, Desmos will kind of automatically put it in a fraction form, so you won't have to worry too much about it there. So let's key that in. We have 5040 divided by parentheses pi. And 8 is our radius, so plug in 8, hit the square button, and then don't forget to close the parentheses here. And that'll give you a degree measure of about 25.066, so I'll round that to 25.1 degrees. Again, I'm going to use my exact number in the calculator, but the theta will be approximately 25.1 degrees. I'll write that on paper. So now I want to find my length, so I'm going to just plug it into that length formula again. L equals theta over 360 times your circumference, which is 2 pi r. So we'll plug in 25.1 divided by 360 times 2 pi, and since the radius is 8, we'll write 8 in there, and we'll get our new circumference, length, excuse me. So let's use that previous degree, hit divide by 360, and then I'm going to hit times 2, second exponent, and then just throw that 8 there. You can type 8 if you want. It really will give you the answer. And it gives me a length of exactly 3.5. And again, if you rounded, you might be just a little bit off, but that length should be 3.5. And since we're dealing with centimeters, we'll write 3.5 centimeters. That's pretty much the idea. We just want to be able to be given one thing and be able to get the other using both formulas. Let's look at that last example. So write this down if you haven't gotten that, and we'll move on to the example with the circle equation. Okay, example 9. A circle's equation is x minus 4 squared plus y plus 5 squared equals 64. Question A. If an arc in this circle has a length of 18 units, what is the degree measure of the central angle that intercepts this arc? The degree of the central angle, that's that theta symbol. Well, what else can we get from this equation? Remember, this is an equation of a circle. And in this, we can find two things. We can find the center, which is the opposite of the numbers inside the parentheses. So the center is going to be 4, -5. That's not going to be super useful for us here in these formulas. But this number right here represents the radius squared. So remember that if the radius squared is 64, we can take the square root of 64, and that's going to give you 8. And on here, if you're not really sure what the square root of a specific number is on a formula, you can use your square root symbol. You press second x squared, and indeed, you're going to get 8 here. So we actually have our radius, so now we can actually answer the question down below. So since we're given our radius, we want to know if the arc has a length of 18 units. That means we're going to use the length formula. So the length formula is theta over 360 multiplied by 2 pi r. Remember, that's the circumference, not the area. So since we're actually given the length and the radius, we can plug those in and solve for the angle. So let's do that. We'll write 18 for L. We'll leave theta as theta. And we'll multiply it by 2 pi, and we're going to put 8 there. So just like the last problems, we are going to multiply by 360 and divide by 2 pi 8. So let's do that. 360 times 18. And then the 360 here, I'll just squeeze that there, and we're just going to cancel those out. And that's going to give you 6480. So let's rewrite that. We have 6480. That's going to be set equal to our theta multiplied by 2 pi 8. And now we can cancel out the 2 pi 8. And like I said before, you can divide the 2, the pi, and the 8 out one at a time. If you have a more basic calculator that you're really not sure can kind of handle all this at once, just make sure that you do it in parentheses if you're doing this specific calculator, or utilize your fraction menu. And while we're on that, I can show you on here, if you're using this specific calculator, you can actually get a fraction in it if you want. You can do alpha y equals n over d. And if you don't want to deal with parentheses, you can just do 6480 and then go to the bottom of that fraction, 2 pi multiplied by 8. And that's going to be your degree. And I'll do it just the old-fashioned way. Sometimes I don't need all the fancy things. I just remember to use parentheses. And you can actually just put 8 after the parentheses too. You don't, after the pi, you don't need the parentheses around the 8 if the pi is being surrounded by the numbers. Anyway, you're going to get a degree measure, and that's going to be your answer. So your degree, your central angle measure in degrees will be about 128 and 0.91. So I'm just going to say 0.9 degrees. And lastly, if a sector in the circle, same circle, has an area of 36 square units, what's the degree measure of the central angle that forms this sector? We're going to approach this very similarly, except that we're dealing with the area. So we'll use the area formula. Degree measure theta over 360 multiplied by pi r squared. And we still know the radius. That's still going to be 8. The a is going to be 36. So I'm going to write 36 equals theta over 360 times pi 8 squared. And we're pretty much going to do it just like the last problem here. So we want to multiply that 360 by 36. It's going to be quite a large number, but cancel those out, see what you get here. And you get 12960 equals theta multiplied by pi 8 squared. And now we can divide that pi 8 squared out of there. We'll get our final answer. Back to the calculator. So take your previous answer, hit divide, parentheses, pi. And I'm just going to hit 8 squared. Trust that we don't need the parentheses around there. And that's going to be your degree. So your degree will be about 64.45. So I'll round that to 64.5 degrees. Again, if you're a little bit off there and you rounded just slightly differently, I don't see that as being the end of the world. But your degree measure is approximately 64.5 degrees. All right, thank you for watching that. I hope that was helpful for you.